Okay. Hello, everyone. Welcome back to another coding session. This is Sajjad, and in today's session, I'm hoping to actually finish working on the interfaces. And I don't know how familiar you are with the interfaces in Rumi, but it's one of the things that I'm very proud of. And we've done quite a lot of works over them in the past. And uh, the start of this session is going to be finishing off the conversion from a struct to an interface, and we can, keep working after that. Hello, Mr. Edmix. How is your day going? Is everything okay? Right. Hello. Let me talk to you a little bit about the structure of a interface in Rumi, and then you can look at the code and see if there are any questions or if there are any suggestions. I haven't had enough coffee to know how my day is going yet. How are you? I'm okay. I'm okay. I just finished my coffee, and I probably need to make another one very soon. But I'm doing okay. I am doing okay. I'm very proud of how fast we are developing the compiler this time, and I can't tell you how happy I am to feel that it is almost about to be over. I mean the base part of it, and then after that it's just going to be expansions of the compiler, or maybe set of standard libraries. And I'm very proud of that. You know, watching your progress is inspiring. Thank you. I do appreciate it. That you come here almost every day. Right. So the interfaces in Rumi are defined in this way. So like any other thing, we have an ID that describes what type we have, a keyword of interface, and then a couple, or I mean, any amount of function definitions. And for example, we defined a printable as something that has a print function that takes no argument and produces units, right? So one example of that would be the test struct that is right to the top of it. So if you look at that, uh, test has a function print that prints the ID in this way, and basically test should be a printable. But we don't generate any conversion directly unless any conversion code, unless we know that somewhere in the code a test is mapped to a printable. So we will only do that if somewhere we have written I is t. You know. So that's what I'm going to work on today. Actually, more like this. So that's what I'm hoping to work on today. Because the base code for interfaces is done. I did it off camera, and for example, the printable interface is generating this code. So we have two structs for each of our interfaces. We have a v-pointer struct, which in this case only has one pointer, and we also have a normal type that has a pointer to this one and a pointer to the struct holding it, right? So these two are generated based on the interface code here, but we need to have the conversion code as well. So if I say, if let's actually declare this as a direct struct, and if I say I is t, um, like so, this should work. And the goal is to implement that. Right. So where should we begin? So I think the place to start the code would be, we should run this and see what kind of errors we get, and then start working from there. I think that's a reasonable approach, right? And if I run the compiler at this point, yeah, it says that I can't explicitly cast the incompatible types. And it is probably because of this one, right? We're explicitly saying that any type casted to an interface is incompatible. And that's not correct, right? We know that there are some structs that we can cast to this interface, so we have to handle those. Right. So to do so, I'm starting to. I will start by looking to see if we are dealing with a struct type. And if so, probably we have to include it. Right. So we will first look to see if we have the struct type available, if we have a struct type, or if it's an integer or something else. And if it's nonsense, we are just going to ignore it. But if we have a struct type, we are going to um, evaluate and see if the struct is implementing our function. So the easiest way to do that would be to add a map to our interface, basically here. And I guess we should do base type here, right? So that it is resolved. Hang on a second. Right, no, you don't need to do base type because base type is handled in the cast. Right. So, is it? I think it should be. If it's not, I'm just going to do that. No, it's not, and we can just do it by calling base type here. And yeah, right. So, so if we have a struct, we need a function that looks at a struct type and tells us if it is implementing our interface has implemented, and we pass in st, and then we return explicit. I think it's called xpcast actually, and has implemented is not defined yet, so we need to define that as a private function, I assume. So let's do that. So private rule has implemented a struct type star st, and let's define a struct type here, so the compiler won't complain. Now, to actually implement has implemented, I am going to memoize it based on a map. So we will have a, I guess set would also work. We don't need a map really. City string structs. Right? So this would be a list of all of the structs who have implemented us. And how do we define the Boolean value? Oh, has implemented, and we get cc and a struct type. Let's pass cc here. So we are going to look at our struct, and basically, so if a struct that has, is it not has? How do we deal with sets in C++? C++ set. Set, it's fine, I think, but let's make sure. right. So begin and our begin, we have those as the iterators. We have capacity, we have modifier, insert array, swap, clear, and place hint, observer, find. Right. So let's look at find, and I think we have to, yes, my setup end. Right. So it's similar to a map. So if struct that find st.id is not equal to struct.end, return true. This means that we have previously made sure that this is implementing us, right? So that's the base case. And if not, we just have to make sure that the struct has all of our methods. So for auto m in methods, um, and then for auto mm in a struct type methods. So if m dot hmm, so if our name was equal to their names matches, to do ensure type matches as well. So if that matches, we are going to um, break from, no, we are going to continue in the outer loop, like so. So does this work? I thought it should. You know what? Let's do the old-fashioned way. So you should have a boolean found, which is false, and then here you should set found to true and then break. Now here, if it wasn't found, return false. Otherwise, continue to the next function. Right? So 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 if we reach here, we know that the struct is implementing all of our methods. So we are going to say struct that insert and then st.id, and then we are going to return true. So the only thing that we have to do is ensure that the types matches, right? So that's the only thing that we have to do. Otherwise, our function is complete, except maybe providing CC here. Ah, um, never mind. We don't need CC there. Who am I kidding? So this should be everything that we had, that we need, right? We just need to make sure that all of the methods is implemented in the struct. Now let's compile that and see if it works or not. And no declaration interface has implemented the struct type. Uh, what? Boolean has implemented. Oh, right. Implemented like so. Okay, there we go. And if I run this, So it says cannot cast types. So do we reach here? Mm, just making sure that the code is working. Right. That finished without any compiler error, and if I run this, we are here. So this function, the has implemented function, is working correctly, but it says cannot cast. Why would that be? Um, cannot cast types. So where is this error coming from? I have no idea. Uh, I can search for that string. It's in assign, and if the type is incompatible, we are saying cannot cast types. But we are saying that we can. Huh. We are explicitly saying that we can be casted, and in the code, we are casting, right? He is a principal at this point. Oh, you know what? Let's make this an implicit cast. Probably something is going on with the cast method and everything, right? I mean, it is an implicit cast in the end, so we don't really need to worry about that. But uh, okay, cannot cast types again. Wow. So let's look at assign. Um, so you're saying we cannot cast types, and that so maybe cast is returning the wrong type in the end. No, that's okay. Uh, an XPRGN. So, hmm. Any ideas where the problem might be? So we are looking at the type of the base expression, and we want to see if it's compatible. So the expression here is a cast expression. And oh, right. So if it's an interface, so right, if it's an interface, we should, uh, we can cast to ourselves. So that should be handled, right? Right. We should be able to cast to ourselves, so that shouldn't really be a problem. And let's see, it is still saying it cannot cast the type. So Let's do, so if t, hmm, you have to look at the base type, and this is okay. So if you're looking at ourself, we shouldn't really cast that. So the problem here is that the compiler tries to cast an struct to an interface. It does that, so the right hand side becomes an interface. So this becomes the printable interface. The left hand side is a printable interface, and it's not sure if it can assign a printable to a printable, and we have to tell it that it is okay. I think that's what's going on. So yeah, that was what was going on, and now it is providing an error because it doesn't actually know how to do the cast generation. Right? Is that correct? Yes. Invalid of size 8. Yeah. So it did that, but now it's not sure how to handle that. Right. So we have to write the cast generation to work around that, and we can do that basically by creating a v pointer. So I'm going to write it. Create the v pointer, and then create the struct, initialize values, and then return all of them. So this is what we need to do, right? So how do we create the v pointer? Well, I am going to assume that we have another type for that. So v pointer should be an LLVM type star called resolve v pointer for an expression, and after we do that, we have to instantiate a generated type, I believe. So next we have to with the LLVM value, LLVM type, we have to create something of that kind. And it would be basically generated type, and we have to create an alloca based on this, so we can use our LLVM builder. So context LLVM, and then builder, and then create alloca of this type. Right? Right. So we create an alloca of that type, and then so I'm worried that this shouldn't be an alloca and it should be a pointer, but we can handle that later. So it won't work in a for loop at this point, but we can work around that. You convert this to a pointer. Right. So we do that, and then we have to initialize the value, and we have two different values here. The first one is the pointer to this expression, and the second one is the pointer to the v pointer. And the order of those is v pointer first and the value second. So we have to do cclc builder create a store, and the store gets the value first and the pointer second. So the value of the first one is v pointer, and the location is actually a GEP, create inbound GEP, or yeah. And this is handled using, I can look at the struct type for inspiration. Right, the aloca, which is v, and the indices. Right, so the indices is a vector. Hopefully what I'm doing makes sense. If not, please tell me. Right, let's actually copy this over, and right, so the indices of the first one should be 0, and the second one should be 0 again, because we are accessing the first element of the object, and we store v pointer to that, right? And next, we repeat the same process only for the pointer to the object. So it's going to be the same thing, basically, only this is going to be indices 2, indices 2, indices 2, and instead of 0, we'll have a value of 1 this time. And here we will have indices 2, and instead of v, we are going to have LLVM value store from e.expr gen. Well, e.aloca cc. Right. So this should be basically as initializing the value of this interface, and then we can return v. So return v. Now, is that okay? I think this is okay. Maybe we need to return a. Do we need to load here? I'm not sure if we need a load or not, but I don't think we do. We can verify that later. Okay. So the only thing that we need is actually the virtual pointer, which is quite easy compared to what we just wrote. And I am going to create another. Well, I'm going to convert this to a map instead of a set, and this is going to go to a void star, right? And here, where you want to insert, you are going to we have to create the v table here. So assume that you have your v table, and you can create the v table as a global value. And to do that, I'm going to take a peek at the previous code that we wrote. Right, so this is the code in the previous version of the compiler. And I can look at the statement structs, I believe. So v pointer. Right. So we need to create a global virtual pointer like this, and it gets or inserts global, and then the name, and then the v table. Right. Right. Okay, that's relatively easy to do. So we just have to create a global value and then access the inside of it. So But we can't do that here because we don't have the CC. So maybe I just store 0 here and then handle that elsewhere. So it's a void star. Right? What's the problem? Let's do it like this, and that shouldn't complain. Right. So we assign it a void star value at first, and then we are going to handle that in the other function. So what's the other function? It's called resolve v pointer, which we can type resolve v pointer struct type star st and then cc. Let's bring cc to the front so that we have a unified way of doing things, right? And here, where we're calling that, we need to pass cc vr and the e dot type cc and then base type cc. Right. And we know for a fact that that's a struct because we don't know for a fact if that's a struct or not, but we can check it. So you ensure e is a struct here onwards. The only other type that can come here is an interface, which we can handle basically by saying if you can dynamically cast e type base type, just return e dot expression generation, like so, and that's dynamic cast. So yeah, so we handle interfaces here, and we know that anything that comes after this is a struct because for all other types we are returning incompatible, right? Right. And now as for a resolve virtual pointer, void star interface resolve virtual pointer. Creating interfaces is always one of the hardest parts in the compiler, but after this step, it would be basically a straightforward thing to do. We just, we are going to make sure that we are reporting errors correctly, and then it is done. The basic part of the compiler is done. So I know that this part seems a little bit hard, and trust me, it is. But this is going to be almost the last challenging part of the compiler. I think we have covered every other part, so I don't think we have any other challenging part, right? So, right. Is my description clear? I'm just asking out of curiosity. Like, do you follow what I'm trying to do? Got I? Right. So, how to do this? Let's bring our inspiration. This part, right? So we need to create a v pointer, a v table, basically, which would be from a global value. So we have to ask the module to do that for us. And we do that by saying cc llc module get or insert global, like so, right? Yes. And the name of the v pointer is going to be challenging. So how do we define the name of the v pointer? We say um, so the name of the v pointer should be a combination of the struct type and the interface type. So auto name would be interface type, I guess. So our ID essentially plus dollar dollar plus st dot id. Right. So that's the name, and vt. Right. So we have to create the visual type. So can we ask if the type exists or not? So if the module has, or get global, get name global, I guess. So if you were able to find it, just return a pointer to that. Get well, let's return it. But if you weren't able to find it, we have to create it. So and it is going to be like a struct type. So LLVM struct type store. What is our struct? Our struct. Mr. Yes, I think I'm following, but I haven't tried to do anything similar. That's fine. I'm doing that so no one else has to, right? Okay. I've done this a couple of times now, so I'm quite familiar with the process. But it is still a challenge to actually write it. Right. So we want to. Um, this would be generated v pointer, and then on top of that, we need to create inside a context, I believe. Thank you, Ismail O. Chabi. Welcome to our stream. Hi, how's it going? So we need a context and a string reference name. Sure, you can ask any question. Feel free to ask anything. Right. So we create a v table and we set it as a global variable, and now we have to set the initializer. It should be gets name global. I don't know. Sure, it's good for backend web development. It's kind of one of the ideal languages, right? Okay, so what is this type? This is an struct type. This is an struct type in that context, and this would be a constant. And right, so previously we've done it like this, and then we would query it again. And I know why we are doing that now, because right, because now we have access to set initializer, right? And we can do that probably, right? And okay, so we can do that. We can set the initializers to init table, and we have to create init table now. And the way to create init table is by by just creating one by creating a vector of constants. And we can set the linkage too. So vtable that linkage with the LLVM global value external linkage, because we want it to be available everywhere. Set linkage, right? Set linkage, not linkage. Now, finally, so let's create our vector of LLVM constants. So this is the actual vtable. Up until now, we were setting up the global instance of the vtable. Now we have to create the actual vtable. And we know the initial members is the length of methods, right? So methods dot size, right? Right. We don't need to do that. So right. So now we can query over all of our methods. Or I'm guessing we can query over all of the methods in st.methods. That makes more sense, actually. Now, init vtable. Yeah, we should get the type of that. So it should get a push underline that init vtable like that, right? So we should push the m dot first dot what is going on here? Second, not first, right? And then actually let's include the method. And now this would be the f, and finally the don't we have the type of f? Seriously? I mean, we can do it like this too. So LLVM function star mf would be LLVM cc dot llc dot module dot get function, and the function would be m dot method dot function dot id. I think that's correct, and here we can get the type. Get function type. Right, and we want to get a pointer to that type. Right, so we want to get a pointer to this type. Right, is this what we want? I think that's not what we want actually. So I'm making a mistake somewhere, and I don't know where it is. So let's backtrack. Let's backtrack, and we want to have a constant struct. I know I've done this in somewhere. Maybe in the code gen file. Oh right, it's here actually. Right. So we resolve the function exactly as I did now, and then we bitcast that function like so. This will give us the location in memory because in vtable we just have to have a pointer to the function in memory, right? So this will give us that. Let's see. And now we are bitcasting that to a number, and we are going to put it here, right? And to finally initialize it, I am going to say create a constant struct and get anon, and so you have init vtable here. What else do you have? You have the value as well, which is the type basically, which would be, so what is our type? Our type is generated v pointer. And then we can return vtable. Right. So that should do it. And I guess we didn't actually use the map, so we can switch this to the previous way it was and switch it to a set instead. Like so. Now, this should potentially work, but I'm going to try to see if it is actually working or not. Okay. So the v pointer cannot convert LLVM type to LLVM value, line 112. So what's v pointer here? It's a value, right? Because we are returning a constant value. Okay. Do you have any other complaints? No? Good. It compiled and we can run it. Right. Assertion t and type get element. This is for type. So we have an error somewhere, and it is probably in one of the types. So one of the types is not matching the other one, GEP type. So it is more than likely in this GEP statement that we had here actually. So right, it could be that we actually want to do exprgen instead of allocogen, but we will find out. Or it could be that this needs to be a pointer. I don't know. We will find out in a second. So let's do that. Arguments of incompatible types. Right. So it is here. The problem is in this cast. But how do we exactly handle that? We are going to peek at here and look for cast gen, I think. Right. So this is, I'm not proud of this one, honestly. And yeah. Oh, so we have to do a beat cast. Right. So you need to do a beat cast here on the. Oh, both of them are v pointers. So that could be the other problem. Anyway, so this is this potentially. Let's create auto struct address, and I can capture this value to that. And here say struct address. Right. So let's do a bitcast on this one. LLVM. No. CC LLC builder. Create a bitcast from our struct address to an int64, I believe, which we can get from LLVM type get int64 pointer type with this context. Right. For the sake of simplicity, we are converting our struct pointer to an int64 pointer, so that the compiler doesn't have to deal with that. And it was complaining that the types are mismatching, and I think that was the problem. But we can make sure. We can make sure in just a second. Right, compilation finished and run. So I guess it's fixed for the first one. For the second one, we probably need a pointer to it for v here. So maybe we can do cc lc builder. How do we handle that one? So we initialize the v pointer. Oh, the v pointer is fine. We get it reset global whatever, and then the create inbound GEP whatever. So this should be fine. The type mismatch is killing me. So So here's a test that I'm trying to do. So I would ask, I want to see if we are at 1 or if we are at 2 or potentially only, in the middle. So let's see where we're getting the error because I'm not sure if it's here or the other one. We have two GEP operations and it could be either one of them. Right. I'm hoping it's something that we can just quickly figure out. But so it's the second one. It is this one. So for some reason, the beatcast is not working. So what's our V table actually? So this is on V pointer, which is um is created up here. The type, not the actual thing. So the V pointer has a V pointer and an int64 pointer type. What's our error? Hmm. Invalid indices for the type. We are looking at the correct indices, right? We are looking at the second indices. That's correct. Hmm. Our type is a int64. Oh, come on. I need a break. Right. So, what are you guys working on? Is everything alright with you? I need to clear my head before looking back at this because I'm pretty sure I'm making a very, very, small mistake. It is probably something that is looking me in the eye, but I just don't know what it is. So I don't want to look at that anymore, at least for a second. Yeah, sure. I should do that. I should do that. Okay, I'll be back in just a second then. Okay, so I'm back. Let's see. Let's see. So I see two possible options. Either we are accessing the wrong indices, which is very unlikely, or we are instancing the wrong type, which is more likely than the other option. So let's look at the implementation here. So here, v pointer, the struct that we are working on, right? Exactly. So v pointer, right? So v pointer is actually, this should be v, not v pointer. That's what I'm trying to say. And this should be v as well, and this should be v pointer. We want to create the pointer to, no, back. So this was correct. So this is correct. The first one is correct. We are storing in v. We are storing v pointer in v, and here we should be storing a struct address in v. Yes. Okay. So we are storing a struct address inside v, which I think is the correct thing to do. At least I hope so. Okay. Compile, and yeah, it compiled. Okay. So let's see what we get here. So we get a printable test s, which means this is a v pointer for the printable interface created for the struct test s. It has a constant value, and it is testing the test getID function. And the test print function, why do we have test print function here? I don't think we need the test print function here. So that's something that we need to fix, because we only the v pointer here only has one value. So let's look at that. We can delete those debug messages. So, for yeah, that's exactly what I was afraid of. So for any method that I have, you need to ask a struct to resolve the method for you. Right. So that's the first mistake. And right. That's the first mistake. Let's try it again. And it should only have the print function, because our interface only cares about the print function. Okay, so that's that. That's there. Right. And then Right. So that's fine. So the v pointer is actually correct. Now about the code. So we handle it by calling GEP on the so we create a printable which is incorrect as we already talked about it, and then we create the pointer to the first element, and we store the v table inside of that, which is okay. Then we bitcast our type. So that's again incorrect. This should be a pointer, not the actual value. So here, wait, right? We are actually we are converting the aloca to the pointer. Okay, and then we are doing a get element pointer, and we are storing inside of that. So the casting is actually done correct if the you know if we solve that, it is completely correct, right? Right. Now we need to handle that. So it gets allocated somewhere on the stack, not on the stack, somewhere using malloc or a similar method. And as far as I know, LLVM doesn't do that for us, and we have to do it manually. So we have to call malloc. If we don't do that, interfaces won't work inside a loop or anywhere else basically. So that's the problem that we have. And okay, I am going to RMBG core. I am going to add this so that we don't lose any progress. Now, for the pointers, so let's see what should change for pointers. So if test s is actually a pointer, yeah, explicitly casting incompatible types. So we have to first change the casting method and then take care of it here. So, and I'm going to put it like this. So if it is a pointer, so if we are dealing with a pointer, and actually import pointer type, try to replace t with the inner type. There is no way. I was really trying not to pass CC to the compatible type, but there is no way to do that. So I'm just gonna change the compatibility code to include CC for everything. But yeah, I'll fix that. So try to see if the inner type works, and when you're generating the code, if it's an interface, then fine. Just check to see if you're dealing with a pointer or not. So um, so if you're dealing with a pointer, I want the expression to be a new pointer um, pointer value, basically, over e, so that we go one layer deep. Pointer no pointer value. This was correct. You just have to import it. so that we force the compiler to go one layer deep. Uh, is it not pointer value? What is the name? It is PTR value, all right. So it should be PTR value with a uppercase P, and I'm guessing this should be a PTR value as well, right? So we this makes sure that we go one level deep, and so the casting is done correctly, and so once we reach here, we are dealing with a strike type, so it's going to be okay. And now I have to change the type for the compatibility and include CC. So I'm just gonna do that, and then change it for interface compatibility. Do that. Oh, do that, and then for other type, I think primitive type to be changed. So yeah, what? Like so, and pointer type should be changed as well. Come on. And then function type. Do we have any other kind of type? I don't think so. Now the implementation of function type. Right, so we come here and we say cc. There you go, and there you go. The implementation of pointer type. There you go, there you go. Primitive type. And what else? So that should be everything, right? Let's compile. I hope so, at least. Shoot. A struct type, right? We forgot about the struct type. A struct. So your compatibility requires ACC, and we are going to do that compatibility, right? CC. There you go. Compile. In casts, we need to provide CC here, and I think in assign as well, right? So that should solve the problem. Named type, right? We have another type as well. So named type compatibility. We have a lot of types actually. Like so, and in here. Okay. Also do that. Compile. Sure. The ASD and the parser compiled, so everything is fine. Now we should be able to try and see if it is actually working or not. Right. So do that. And it is working for a pointer. So the way it does that is that It loads the pointer and then it does the rest of the operation. I think this is correct. I might be wrong, but I think this is correct. Right. So let's actually let's compile it and see if you get any errors. Right. So that worked. Now we have to let's add that. Now in our test function, we have to call something on the interface, and I think the best thing to do would be to just call the print function. I mean, the only thing that we can do is calling the print function, right? We can't really do anything else. Right. So how does that work? It's going to complain that can't call method on non-struct, but we know this is a struct. So we have to go to method, the method call .cpp. Yeah. So there's a chance that shoot, so it is trying to compile it for a. It is trying to. Hmm. This code works if the underlying type is a struct. We know that our underlying type is not a struct, so here instead of actually producing an error, we should try to call it on an interface, right? So here, let's change the way our method call works completely. And method call should have a boolean value indicating if it's a is interface, and it's going to be false by default, right? You know, we are not dealing with interfaces normally. So when you reach here, instead of actually giving us an error, try to compile interface. Let's do it like compile interface with CC. Okay, and you have a void compile interface. Interface gets a special treatment because they are a special thing in our board. File interface cc cc like so, and this one moves there, right? I mean, at some point we have to produce the error. Now the other thing that changes, you don't want to do any of those things anymore. You want to return, right? Right. And then the next thing that you want to do, so in our expression generation, instead of just calling function call expr generation, you have to look to see if you are an interface. So if you are an interface, you want to call exprgen interface, because you know the type is going to be different. And I'm wondering if this is going to be okay. So let me write that. It is going to be a void star xprgen interface. We get that. And the next thing will be the type. So if it is an interface, the type result would also be different. So you would have to do type interface. So type star type interface. Right. Now we just have to write these three methods, and then we can try to see if the whole interface code that we have written is actually working or not. But we won't know until then. Okay. How long has it been? It's been, come on, an hour and 24 minutes. Wow. I'm getting too tired for this. And I hope to stream for at least 2 more hours because, I want to get a lot done. The compiler should be done, really, really soon. Right. So, we take a similar approach. So we try to find a base type, and this time it is going to be an interface. So let's just study that we might be looking at an interface. Yeah. So I would be a dynamic cast to interface star from BT. And if I isn't available, it might be a pointer. So do the same thing. So if it's a pointer type, and you can dynamically cast it from a pointer type BT, then I would be the result of a dynamic cast from your pointer type a star and pt dot inner type dot base type, and what the fuck is that? Right. Next, so if you can't still find I, now you're going to produce an error, and you're going to say I can't call method on non-structs or non-interfaces. Interface. This should be an interface, actually. Right. Okay. So that's our type result. And I am going to open this one on the left side as well so that I can cheat. Now we want to find the method, but we know that this time the method is we don't have a method, we have a function signature. So fsig would be I dot resolve method. You get your CC and you get the function signature. And if you didn't find fsig, just complain that can't find method, whatever it is, on space on interface, whatever this is, and then exit forcefully. Right. Right. So that's correct. So that's correct. And now We want to add ourselves to the first argument and do all sorts of different things. Well, we don't need to do these things here, because the interface call is different from other types of call. So at this point, we are just going to say, okay, I want to find the index, right? So maybe result method should actually return the index, or I can get method index would be the method index cc expid. So we store that. We don't really need to work with the function signature. Well, we do need a function signature, but we also need to do that. And that would be our compile, right? No, something is missing, and what is missing here is we have to capture the other elements, right? I really, I'm really not motivated to continue working on this at the moment. Like, I need a serious break because I think I'm making a mistake somewhere and I don't want to continue if I am. So I think it would be a good idea to pause this at this point. I wanted to stream for 2 more hours, but I really can't. I hope you guys understand. Um, I'll try to work on this on my own because this requires me to write on paper and validate the order of the pointers and things like that. But I'd be happy to discuss this tomorrow. Sure. Thank you, Mr. Edmates. I really appreciate your support. I'm going to do that. I'm going to take a break. Anything you guys want to talk about? I know there aren't many people in chat today. Like I'm used to having a lot of people in the YouTube chat, but since coming to Twitch, this is really there aren't as many talks here. Yeah, sure, I will. So the code is I'm not sure if you saw the code. The code is here, and I will talk about it, like the process and how we do it. Um, it is already done in the older code base, but the way we handle that is not really pretty. So the way we handle that is, it's just a bunch of mess, and it's all grouped together in one big function. I really don't like that because that's not modular, and I wanted to have a modular compiler, right? So I want to be able to expand on it as we go on, and we actually hit a point where we couldn't expand, so I had to stop doing that. And the code we are going to generate is going to be exactly the same code as here, only that the way the compiler is structured is going to be different. So yeah, I will update you guys on how we solve that. Um, I will show you the code. Uh, Probably tomorrow. I will work on this today, and come back tomorrow. But yeah, thank you for your support. I really appreciate you guys being here, and I hope to see you, you know, another day, tomorrow or another day. Have a great day, and bye bye.